Okay, we're wrapping up week 5, Wednesday, February 12th. Introduction to networks. The students did some review of the conversions. Talked about that later. Talked quite a bit about the data link layer. Got just a couple things left to finish up with that. And we did quite a few switch configurations. I'm looking ahead. OSI model. Oh, also, March 1st, all financial aid things need to take care of. OSI model. We talked quite a bit about down here. We talked about the data link layer, logical link control, talking to the layer up, media access control, talking down. So we have some type of media, it could be wire, fiber, or wireless. And the physical layer figures out how to put it on the media. But this is the data link between the two devices. We call it a frame when it's at the data link layer, and it has the addressing for the data link and then the payload. And we're going to talk a little more specifically about that on Monday. The next layer up is called a packet, and so we would strip this off, and inside here would be some addressing for the network, and then a router would decide where to send the information, which port to send it back out of, and then it would be re-encapsulated with the next data link protocol between it and the next device, put on the medium, get to the next device, and then repeat the process. Let's look at some more details. So here it is again. We can talk about it again. When data comes down, we split it into segments, and then it gets port numbers and so forth, transport layer. We talk specifically about that later. Then when we put IP networking, the IP address on it, the network layer, which is going to figure out the best path. Okay, so now it's called a packet. And then when we do the data link addressing, how are we going to put it, how is it going to communicate on the median between two locations? And then go back up the model. There we call it a frame. Okay? Now let's look at some diagrams. We start out here first talking about, we got the switch in which we have our Windows machines on, and then we have a switch in which we have our Linux machines on. And then we started adding these extra switches on top of the tables. We're going to move the Linux boxes for a while, okay, here coming up. Then we have this connection to like a routing device. And so the data link layer allows us to make this connection between here and here, okay, or it could be from here to here. We have some kind of addressing that allows us to make that connection. Then the router routes it either sends it here, here, or this way. This way, let's say if you're going out to the internet. Now in here we have some, I'm going to use some different colors. This connection here from this wiring closet goes to another wiring closet and then goes out in the internet. When it gets out the internet, these routers use data link to set things up in order to communicate to the next location. Now the network layer, the routing layer, will make a decision. Does it go this way or does it go this way? Once it decides which way, then it goes down to the data link, and that makes the connection so the information frame can move to the next location. Take the framing information off, look at where it needs to go, and then, in this case, the internet, could it be this way, this way, this way. Okay. Now, internally here, we looked at, we talked a little bit about this default gateway for the Windows machine, and then we talked about the default gateway for the Linux machines. It's that next hop where it's going to go, the information. Okay? Then, so this was, when we had the IP addressing, talking about the IP addressing out here, this represents more of a logical diagram, topology. But then we started to convert it into a physical one because we started doing some things like we showed how this equipment is in PC 228A, and then I'll use another color. We have a wiring closet up here that this multi-layered switch connects into there. And then we also from the switch have a connection to MH216. And then there's another room. I can use another color. I'll use yellow. Where the servers are. So that's another location too. And I showed a little bit. We're going to, on Monday, diagram that all out as a review of the data link layer and the topologies. We did some conversions, hexadecimal number, so each one of these would be 4 bits, so this 2 is represented here, one group of 2. This 1 is represented here, 4 bits. The 0 is represented up here, and that 2 is represented here. This was a configuration register in a router. And we showed a configuration register in a switch, which would be F. Okay, so we have O by, and those are registers where the bits are stored. So these bits would all be actually in a row there. And then they represent something to the router in terms of how it boots up. Okay, then I said if we have 172, what is that? Binary, so we took one group here, one group here, one group here, and then the 12, actually ends up being 44. Yeah, let me redraw that. I'll take those off of there. So we took 172, we took one group 128 out of it, and then got 44. Then we took a group of 32 out of that and got 12, and then we said 12 is represented by those 2 ones. So that's a binary representation of this decimal number. Then we took a binary number, converted it to decimal. So again, thinking about these numbers up here, okay, we have one group of 64, one group of 8, one group of 4, here, 64, 8, 4, and one group of 1, 77. Then we looked at this. We split it into hexes. I'm going to use another color. Divided into 2 hex. So these 4, what would they represent? Standing by themselves. So 2 to the 0, 2 to the 1, 2 to the 2nd, 2 to the 3rd. So that's one group, so that'd be 4. And then over here we got one group of 8, one group of 4, and one group of 1. So that's 13, so we mark these off, and 13 would be a D. So 4D, represented as binary, would be this, and represented as decimal would be that. And you could figure that out. You can take, this is, so if this is a hex, this is 4 group of 16, 4 times 16 is 64, and D is 1 group of 13, 777, checks out. Talk about some topologies. We started here, actually, we started out with a star topology, or a hub and spoke. We talked about these connections. Then we turned it into a mesh topology in network, in any kind of communications. You talk about a bus, you got a main line, and then things are connected. This would be similar to like a motherboard. We got a bus that connects the processor, connects memory, connects the slots, maybe connect a hard drive. They all communicate through that bus, ports. A long time ago they had what they called a ring. They used token ring protocol, in which everything was connected to the ring, and then you passed a token around. Whoever had the token could communicate on the ring. You don't see that anymore. Last slide. Carrier sent multi-access collision detection. We used to have hubs before we had switches. We don't use them anymore. The switch technology is so much better because in a switch you really don't get collisions. Okay, so we have full duplex, so devices can communicate through the device, and it can buffer, and then we don't have collisions. Here we used to communicate through the device, you had to take turns. So this one would check, as long as there wasn't a collision, it would put its traffic would get broadcasted, and then whichever place it was supposed to go, whichever MAC address matched in that case, it would go there. Big problem with that, everybody could see everybody's traffic. And then you had to wait, if if there's a collision, 2 people try at the exact same time, there's a collision, then they both wait a random amount of time, and then they try again. So, good thing don't have those anymore. And we have switches. But access points still use this concept right here. Carrier sense multi-access. It senses, you have a device out here. Let's say you have a laptop, and it wants to communicate to the access point via wireless. It's going to check, and if it's available, then it's going to start transmitting. So it's collision avoidance. Collision detection up here, collision avoidance. So when you get lots of devices connected to an access point at the same time, even though any one of them is transmitting at their speed, they still might be waiting for other people. So it appears to be going slower. That's it.